Welcome to our channel Physics Cat, and it is the second lecture in this series that I am about to begin with immense pleasure. And I will try to solve CSIR December 2011 PYQs about the topic statistical mechanics with a great care. Thank you. Okay, let's start. Okay, so the first question: the internal energy E of a system is given by E equal to something where B is a constant and other symbols have the usual meaning. The temperature of this system is equal to, okay, this is easy. So first 38. Okay, so you are given that E equal to B is Q by Vn. Okay, you need to find the temperature of the system. Okay, so you know dq equal to du plus p dv minus mu dn, where mu is the chemical potential and v is the pressure and du is the internal energy. dq equal to the absorbed or emitted heat by the system. Fine. And this is the first law of thermodynamics, so you can write it dq equal to tds equal to du plus p dv minus of mu dn, right? From here, if you need to calculate this t, okay, so t equal to, you can write du ds, okay, where v and n constant, because if v is constant then dv equal to 0, n is constant then dn equal to 0, so this two term is will be cancelled out. Fine. So du ds, you can write it d ds v and n, and you are given E equal to bsq by vn. Fine. So simple derivative with respect to s, so you will get 3 s square b by vn. This is the answer. Okay. Okay, the next question, 43, right 43. Given that, consider a Maxwell distribution of the velocity of a molecule of an ideal gas. Okay, let v most probable velocity and root mean square velocity denote etc, and you need to find the ratio of v most probable by v rms. Fine. So 43, right? Okay, so I think you know v rms equal to root 3 kt by m and v most probable equal to root 2 kt by m. Okay, and from where you are getting this, you know if nu equal to various b square exponential minus mb square by 2 kt, and then you will find del f del v equal to 0 for maximum or minimum, and from here you will get vmb. Okay, and this is equal to root 2 kt by m. Okay, you need to remember this. Okay, and root mean square velocity is root 3 kt by m. Okay, you can go through in the book. Fine. So I just simply I need to calculate the ratio, so vmp by vrms equal to root 2 by 3. This is the answer. Okay, next question. Next question, it is given that if the number density of a free electron gas in 3 dimensions is increased 8 times, its Fermi temperature will be. Okay, so this question is coming from the Fermi gas chapter, statistics. Okay, so I think you know 44. I think you know Fermi energy. Fermi energy EF equal to h cut square by 2m 3 pi square n whole to the power 2 by 3. Okay, and also you know TF, I mean Fermi temperature, EF by kV. Final substitute this and you can find the mean energy U equal to 3 by 5 EF. Pressure, you can find the pressure P equal to 2 by 5 NEF, etc, etc. So I just need this equation. So here we can write EF varies in by this thing. Okay, now you can find easily EF1 by EF2 equal to 8 n1 by n1 whole to the power 2. So this n1 will be cancelled out, and 8 equal to, I can write it to 2 to the power q, so 2 to the power square equal to 4. Fine. So the answer is increased by a factor by 4. Right. Okay, next question. Okay, next question saying that a gas of n non-interacting particles is in thermal equilibrium at temperature T. Each particle can be in any one of the possible non-degenerate states of energy 0, 2e and 4e, the average energy. You need to calculate the average energy. Okay, so this is very easy question, just you need to use a formula. So 6 2. So here three system are given, sorry, three state. Okay, so 0, 2 epsilon, 4 epsilon. Okay, and there are total n number non-interacting particles. Okay, so we need to evaluate the average energy, and you can see that this is 0. So 0 e to the power minus 0 by kt. Why 0 by kt? Because we know e to the power minus beta I, where beta equal to 1 by kt. So e equal to 0 plus 2 epsilon e to the power minus 2 epsilon by kt plus e to the power minus 4 epsilon by kt by e to the power minus 0 by kt plus e to the power minus 2 epsilon by kt plus e to the power minus 4 epsilon by kt, right? And then this term is 0. Okay, so you can take common 2e into e to the power minus 2a by kt, 2e by kt plus 2e to the power minus of 4e by kt. You can write it by denominator term 1 plus e to the power minus 2a by kt plus e to the power minus of 4e by kt. Okay, and there is a condition given that b epsilon very less than 1. So you can write b equal to 1 by kt. So epsilon by kt very less than 1. Epsilon less than kt equal to kt. We don't need this. Okay, this is enough for. Okay, so epsilon by kt very less than 1. If this is nearest to 0, near equal to 0, then this e to the power 0 equal to 1. So this term will be 1. Okay, so you can get 2 epsilon into 1 plus 2 by 1 plus 1 plus 1. Okay, so you will get 2 epsilon. This is the answer. Very easy. Fine. Next question. Okay. A one-dimensional chain consists of a set of n rods, each of length a. Okay, when stretched by a load, each rod can align either parallel or perpendicular to the length of the chain. The energy of a rod is minus epsilon when aligned parallel to the length of the chain, and epsilon when it is perpendicular to the chain. When the chain is in thermal equilibrium, then average length. Good. To 63. So we need to find the average length. Okay, so mean length I am foreseeing it is v. So you can write a e to the power beta I by e to the power beta I plus e to the power minus beta I. This is for parallel, this is for antiparallel, right? Sorry, perpendicular. Okay, and from here you can write a by 1 plus e to the power minus 2 beta I. Good. Okay, now you can find the average length, and it is n, because there are n number of sets. Okay, and each of length a, so na by 1 plus e to the power minus 2 epsilon by kt. This is the answer. Fine. Next question said that the excitation of a three-dimensional solid are bosonic in nature with their frequency omega. Okay, and omega varies k square in the large wavelength limit. If the chemical potential is 0, then the behavior of the specific heat of the system at low temperature. Good. So 71. Fine. Please, 1 minute, please. Okay, so you are given omega varies k square. Okay, so you can write it h cut omega varies h cut square k square, because h cut is constant. You can write it. Okay, h cut k whole square, and you know p equal to h cut k, so you can write epsilon varies p square. Okay, and you can write d epsilon varies 2p dp. This is 2 is constant, so p dp. Okay, good. And p equal to root epsilon. Okay, sorry, equal, not equal to, this is various. Okay, and from here you can write dp equal to, sorry, dp d by root e, right? Okay, from here p varies 1 by root e d. Okay, now d of okay, density of state, you know, d e equal to 4 pi square by h cut cube p square dp, and then substitute this. Okay, so d of e varies p square dp. Okay, and p square equal to 1 by e. Okay, varies e d by root e. Okay, and from here you can write root e d. Good. Okay, now from the condition of Bose-Einstein condensation, you can write u varies 0 to infinity e d by e to the power minus of beta I minus 1. Okay, now I am considering beta I equal to a. Good, and here substitute the value 0 to infinity epsilon and d epsilon already 1 by 2, so 1 plus 1 by 2, so e 3 by 2 d by e to the power minus of beta I minus 1. Good. Okay, so I can write also e to the power 3 equal to e to the power 3 beta to the power 3, because this is all constant. Now substitute this here. Okay, so you will get epsilon whole to a to the power 3 by 2 dA by e to the power minus a minus 1, right? And this 1 by beta whole to the power 3, and you know this whole term is constant. Okay, so I can write 1 by beta to the power 3 and beta equal to 1 by kt, so various to the power 3. Okay, and this is the answer to the power 3. Okay, and then 772, it is said that gas molecules of mass m are confined in a cylinder of radius r and height l. Okay, vertically in the Earth's gravitational field, the average energy of the gas at low temperature, m is very greater than kb2, is given by, okay, it can be solved by virial theorem easily. Okay, I am here using, so you know average energy equal to f by 2 kt, right? And for this low temperature, because it is said that this whole system is in low temperature, so only the translational motion will come, no rotational motion, so degrees of freedom is 3, and here f equal to 3, so 3 by 2 kt, so this is 3 by 2 kt, and from virial theorem we can write v equal to kt, right? And then e equal to t plus v. This is so simple, so 3 by 2 kt plus kt equal to 5 by 2 kt. This is the answer. Okay, but it is also said that for n particles, okay, 1 minute, for this is for 1 molecules, this is for 1 molecules, for n molecules 5 by 2 n kt. This is the answer, right? Okay, so enough for today. Thank you.